Okay, so we're going to tackle another problem. I guess I'll go in order. I'll go down to B. And we're going to try to find the modular inverse of 388 mod 413. And so we want to find the modular. We want to find, whoops, what is that? That was fun. We want to find the modular inverse of 388 mod 413. Okay, so that's our big goal. So we're going to start that by, again, first finding the GCD and then working backwards. So we're going to start off with 413, and we're going to say 413 is equal to what times 338? 1 times 388, plus there's going to be 25 left over. 388 is equal to how many 25s? We can fit 10 of them is 250, 15 of them, I think it's everything, is 375, and then we've got 13 left over. And then 25 is equal to 1 times 13, we can't fit 2 of them, plus 12. 13 is equal to 1 times 12 plus 1. 12 is equal to 12 times 1 plus 0. So we can see that the GCD is 1, and so what we want to go ahead and do, so from here, GCD of 413 and 388 is 1. And what we want to do is we want to work backwards now. So we're going to start from that 1. We're going to say 1 is equal to 13. So this is working with this line here. 1 is equal to 13 minus 1 times 12. And from the line above, 12, if we move this over, 12 is equal to, so this is 13 minus 1 times, instead of 12, we're going to say 25 minus 1 times 13. And that becomes, we can tidy that up. We've got 2 13s in that mix, so 3 times 13 minus 1 times 25, I think. And that looks good. And then we're going to go up one more line, and we're interested in that because of the 13 here. So this is the same as 3. Instead of 13, we're going to call that 388 minus 15 times 25. Minus 1 times 25. And so that's an alternate universe version of what 13 is equal to. So here we have 3 times 388, and we've got minus 45 25s and minus 1, so minus 46 times 25. I'm just expanding that out. Okay, and I think I got that right. Minus 45. Yeah, I don't know why, but for some reason I thought that was wrong. Okay, and so now I've got the 25, which I'm going to use with this. So I've got, this is the same as 3 times 388 minus 46 times, and now this can be a new version of 25. It's 413 times 413 minus 1 times 388. Okay, so now if I move all of that together, I get, that's 3 times 388, and from the inside we're going to get plus 46 times 388, so that becomes 49 times 388 minus 46 times 413, and we should check that that works itself out. If we calculate that out, somewhere back here, I felt like I had done something wrong, and I don't exactly know why I thought that. I'm still looking at that. 3 times 13. I need a calculator. Oh, I did. I knew I had done something funny. Okay, I'm going to back it up. It's not a lot, but this is where it's going to come into play. I'm going to just stop right here. I thought I saw something that looked odd, and I stopped, but I didn't stop long enough. So at this point, I'll show you what I stopped around here, and I was confused. Something felt wrong. Here I have 113, and here I have minus 113, which is plus a 13 overall. And so together, they don't make 3 13s. They make 2 13s. And so this number, the whole way down, is wrong. That should be a 2. 2, 2, 2. And did it play out elsewhere? Here it did. This is when I first noticed it too. I should have just stopped. Something just felt off. So let me just erase and make a better answer here. So this coefficient was off as well, because this is 2 times 388 minus 2 times 15. So minus 30 minus 1. So this should have been minus 31, and this remains 2. And this becomes 31 as well. Okay, I feel like this seems more reasonable. So here we have 2 times 388, and then I've got minus 31 times minus 1, so plus 31, or 33 times 388 minus 31 times 413. Okay, why I thought that felt wrong, I have no idea, but there you have it. And so 1 is equal to 33 times 388 minus 31 times 413. And so what we're trying to find is the modular inverse of 388 mod 413. Okay, so that's grand, because what we can do is take both sides mod 413. That means this is 1 on the left-hand side is equivalent to 33 times 388 minus 31 times 413, all mod 413, right? And so this is, that goes away. That's equivalent to 0, right? So this is all equivalent to 33 times 388 mod 413. And this is why this approach works, because once you get it in that find Bezout's coefficients, if you can find the modular inverse of either, and so here we have 33 and 338. If we multiply them together, they give us 1 mod 413. And so the modular inverse of 388 mod 413 is 33. Okay, So that is, those are the steps that we need to take in order to do that. And we can go ahead and do that for a few others. But that's the win there. That is the approach that you're going to take for each one. So you can break here and try it yourself. But if you were finding it for 897 and 770, you're going to start off exactly the same way that we just did, where you're going to say 897 is equal to 1 times 770 plus 127. 770 is equal to 6 times 127. 607. Yeah, okay. 600, 720 plus 43, 763. And so we have 7 left over. Is that right? 120, hold on. 6. So that is not right. 36, 42, and 120, 12, 16, 1, 6, 7, 62. I was off by 1, and off by 1 error of a different variety. So we're going to add an 8 in there. And so 127 is equal to how many things times 8? We can fit in 10, 80, plus another 5, 15. And then that's 120. We'll have 7 left over. 8 is equal to 1 times 7 plus 1. 7 is equal to, and you can see that this is where we're going to stop, right? So 7 is equal to 7 times 1 plus 0. But it's good to work it out. And so that gives us that GCD right there. I don't know why I always have it on the biggest setting for the highlighter, but there you have it, the 1. Okay, and so GCD of 897 and 770 is 1. Grand. Okay, and so then we can work it backwards. And this is when we find Bezout's coefficients. And so I'm actually going to do it this way because I think I think of it in this orientation. So 1, so I'm just going to put a little star next to the first one. So we're going to start with this, and then we're going to work our way up. 3, 4, right? So this is where we're going to start. 1. 1 is equal to 8 minus 1 times 7. And 7 is equal to 127 minus 15 times 8. And that's from, so that was from 1. This is from 2. And we can expand it out. So that's 18 plus 15. So it's 16 times 8 minus 1 times 127. And then that, though, if we look at 3, we can expand out that 8 to say, well, that is the same as 770 minus 6 times 127. And that's from 3. And we can say, okay, well, let's, oops, I lost sight of something there. Hold on. It is from 3, that part, but we need to keep the bit from above, minus 1 times 127. Okay, this part is still from 3. And I can expand it out. So that's 16 times 770 minus, and so we have minus 1, but then we've also got the 16 times minus 6, so minus 96, minus 97, 97 times 127. Okay. And then from 4, we can see we've got that 127 there. We're going to say this is another way. We can also write this as 16 times 770 minus 97. And instead of 127, we're going to write that out as 897 minus 1 times 770. And that is direct from what I had labeled on the left as 4. Okay, so now I can clean that up and I don't need any more equations. This is 16 770s and positive 97 770s, so I can add those together, which is the same as 13 plus 100, 113 times 770 minus 97 times 897. Okay, and so since that's all equal to 1, I can say therefore 1 is equivalent to, and I want to work with 770 mod 897. So that if I put this under mod 897, this is just going to go away. So this is 113 times 770. And I'm going to just get rid of those so I can see it. Mod 897. Okay. And what that means is I do check, but I'm trying to find the modular inverse for 770. And this value is in the right range. It's between 0 and 896. And so I can stop. So the modular inverse of 770 mod 897 is 113. Done. Okay. Last but not least is this last one. And I think smaller numbers, it's probably going to be a little more straightforward. So we'll start off with finding out how this breaks down and finding the GCD. 379 is equal to 1 times 254 plus 125, 254. I can fit 2 of them, so 2 times 125 plus 4. That's lucky. We're getting down to small numbers pretty quickly. 125 is equal to a certain number of 4s in there. I can fit 31 of them, and I've got 1 left over. 4 is equal to 4 times 1 plus 0. So immediately that gives us the GCD of 1. We get a lot of practice with that. GCD of 379 and 254 is 1. Okay, and that means we can find a Z linear combination of 379 and 254. We can find the Bezout's coefficients, and we can write it out as S times 379 plus T times 254 based on everything we've done. And we do that by working our way backwards. And because I think it's helpful to kind of look at that side by side, I'm going to move things over and we'll see. I'm going to call this 1, 2, and 3. And I'm going to move my way up, but I'm going to start from 1. And so starting from 1, what I know is I can write 1 as 1 is equal to 125 minus 31 times 4. Okay, and I'll say by 1. And then I can say, but that is equal to 125 minus 31. And instead of 4, I'm going to replace that. I'll move this over as 254 minus, 2 times 125. Okay, and that is by 2. Okay, and I'll clean that up. I've got 125, and I've got plus 62 125, so that's 63 times 125 minus 31 times 254. I just pulled the 125s together. But now from here, I've got that 125. I can split it up again. And I can say that's 63 times 379 minus 1 times 254 minus, and now we're going to keep this bit from above, 31 times 254. And that is from 3. Okay, so cleaning that all up, that's 63 times 379 minus 63 times 254 and minus 31 times 254, so that's minus 94 times 254, and so now we have that 1 is equal to 63 times 379 minus 94 times 254. So so I could write it out as 1 is equal to 63 times 379 minus 94 times 254. And if we wanted Bezout's coefficients, this is where we would stop. We'd see it's 63 and minus 94. Those are Bezout's coefficients. But what we want right now is the modular inverse of 125 mod 254. And so what that tells us is we can take both sides mod 254, and that means that on the left-hand side, that's 1. On the right-hand side, this just becomes 63 times 379 under mod 254, because this becomes 0. Right? Okay. It's a multiple of, and so it's equivalent to 0 mod 254. Okay, so then that gives us what we need. 63 is the modular inverse of 379 mod 254. Okay, and if I had asked the modular inverse of 254 mod 379, it'd be minus 94. So you can kind of see where this is going. It's an interesting space to play in, and that's the last problem under this series.